right, good afternoon, everybody. Welcome to the SEDAC presentation, overview of COMcheck and REScheck programs. If you have questions during the presentation, feel free to use the question and answer window to enter questions to us. If you put them in the chat, we might miss them, so please do use the question and answer window. If you hover at the bottom of your screen, you'll see the Q&A option there. I will hand it over to Ryan now to start us off with introductions.
Well, thank you, Sean. Well, welcome everyone to today's webinar, and want to provide a little bit of housekeeping here before we begin. As far as credits, today's program is being recorded, and everyone who is participating today will receive a certificate of participation for reporting of their credits. For those who may need ICC or AIA credits, when we provide you that certificate of participation, if you would go ahead and reply back with your ICC or AIA member number, and we will go ahead and get those reported into the system for those individuals. Also, today's presentation will be made available along with the recording on our website, SEDAC.org, after today's presentation here. So as far as what we're looking to cover today is COMcheck and REScheck, some of the basic functions, along with identifying some of the information on construction documents that's needed for entering into COMcheck and REScheck for compliance. Also looking at some of the output reports and how to consider addressing non-compliance for this. So a little bit of background about who we are. Sean and I are part of the Smart Energy Design Assistance Center, or SEDAC, which is housed at the University of Illinois in Urbana-Champaign. And we also are a public-private partnership working with 360 Energy Group out of the city of Chicago. Our primary function is to reduce the energy footprint across the state of Illinois. That includes both the public and private sector of the state of Illinois. And our work with the Illinois Energy Code is part of how we look to achieve that goal. For those of you with projects in the state of Illinois, that could be building owners, occupants, design professionals, code officials, and the like. We do have technical support assistance available for the Illinois Energy Code. If you do have questions or need some technical support assistance, please go ahead and reach out to us through our email address, energycode@sedac.org, or we do have an 800 number available for you. We do have several online resources at our website for the Energy Code, sedac.org/energy-code. Some of those resources include recordings of our previous workshops and webinars, along with several online on-demand training modules. Those modules are designed for a little bit more of an introductory audience. So those people who may not be as familiar with code can have some benefit from using those online training modules. We also do have several links to both the International Energy Conservation Code, along with the Illinois amendments and City of Chicago amendments through that website. So rather than necessarily needing to remember a big long website string, you can always come to our Energy Code website and link to those directly from there. So as far as some things we do have upcoming here, we do have a couple of more online workshops yet scheduled for the current program year, which ends at the end of June. One of which coming up later this month, covering the key requirements for the Illinois Energy Code on the commercial sector, and then a week later covering the residential section. So those are each an hour and a half. Today's session should be approximately 1 hour, and we will try to get to the questions either during the presentation or at the end. So with that, I'm going to turn it over to Sean to talk a little bit more about the COMcheck.
All right, thank you, Ryan. So first thing to be aware of, both COMcheck and REScheck have desktop and web versions available. The plan is to phase out the desktop versions and go to completely using the web version for doing COMcheck and REScheck work. Um, the benefit that provides is that it lets them store an online database of buildings and stuff for data mining purposes and things like that. Um, but also it's easier to maintain that single source than to try to maintain both program sets. COMcheck is a prescriptive and UA trade-off compliance path option for energy code compliance. It does not have the ability to do performance simulation or any of the other compliance paths. And most commonly, it is used for doing UA trade-offs for different assemblies within the building. Um, the way process flow works in COMcheck, you'll enter some basic project information, um, things like building type, floor areas, and then you'll move on to building envelope components, um, putting in the actual areas for envelope components such as fenestration, walls, roofs. And then you'll step into a lighting section where you'll enter in details about indoor and outdoor lighting. Both the building area and space by space lighting methods are included in that as options. And then you'll enter in some mechanical details. And finally, there are checklists for compliance verification that are included at the end of the program and contribute to the compliance reports for the program. You did have a question. COMcheck and REScheck both are phasing out the desktop versions of COMcheck and REScheck, and they're moving eventually towards only having the online data entry for those programs. And the reason they're doing that is, one, it allows them to store an online database of buildings and things for data mining and research purposes. And two, it's easier for them to maintain one program set than it is to maintain both desktop versions and the online versions. So to cover the first steps in data entry in COMcheck, you can see here this is the COMcheck web interface. Most of the screenshots we'll have in this presentation came from that web interface. Looks very similar to the desktop interface, so there shouldn't be any confusion there as far as appearance and where to find things. But some key important things: make sure you select the proper code for your compliance option. If you don't select the proper code, you may get incorrect results. Make sure your proper state and city are selected because those will determine your climate zone, and that has an impact on the R value requirements and such in the program. You can select a project type: new construction for a whole building, additions, renovations if you're doing work like that. Those have a minor impact on the program as far as how much detail you have to add. Building area types are entered in the block on the right there. You can see the red text for select an area category. And you can enter in multiple building areas for a building, or if you're doing the space by space method, you'll enter multiple space areas there as well. And that will contribute towards the lighting tab that will populate your wattage requirements and things based on the code tables. You'll also select here your efficiency package options for the prescriptive path. Those options again include high efficiency lighting, improved envelope, some air leakage, reduced air leakage options. Each of those has some help text associated with them. If you click, there's a little question mark next to that drop down. And that help text will explain each of those options and any impact it'll have on future choices in the COMcheck program. And again, each of these selections will pre-populate options in the envelope and lighting and mechanical tabs. As far as the phase out, what does that mean for those that have the program on their computer? Eventually, they will stop updating that program. So somewhere down the road, I'm not sure when the phase out is going to happen. We don't have a firm timeline on that yet, but eventually they'll stop updating the desktop versions with new code versions and corrections to any internal formulas. So those desktop programs will eventually just stop being updated. And so if you're using the desktop version, eventually somewhere down the road you will have to upgrade to using the online version. As I mentioned, the online versions are very similar. Data entry and everything is handled the same way. It's just a web interface instead of a physical desktop program. So once you've got some basic project information entered in, some things we do want to make aware to you. Depending on the efficiency option selected, COMcheck may limit your future entries. So if your efficiency package option for your prescriptive path compliance is the high performance HVAC systems, that's going to limit which systems you can select in the mechanical tab. You won't be able to select constant volume systems or dual duct systems with mixing boxes at the VAV level. Mostly because those are less efficient systems, and so they don't meet the requirements of that high performance compliance path. If you select reduced lighting power density as the efficiency package option, that's going to reduce your lighting power on your lighting tab by 10%. So the allowances that the program is looking at and displays for you for reference will have that reduction automatically included. The web version currently has a restriction where you can only use the building area method if you're using the reduced lighting power density method for the current codes. That is not a code restriction. It is a holdover from the IECC 2012 version, which restricted the use of reduced lighting power density as compliance path to having to use the building area method. We've actually got a request into COMcheck to get this corrected, and they've replied back that in the next update they will try to correct that. So the desktop version doesn't have that restriction and shouldn't, and the web version will eventually be corrected for that. But it is something to be aware of right now while they're supporting both. If you're planning to use that reduced lighting power density method in combination with a space by space entry method for your lighting, the desktop version is going to work properly for you. There should be notice from the producers of COMcheck and REScheck when they make this conversion. I would assume that they would announce that to any registered user for their program. So once you've got your building areas entered into the program and your basic project data selected and entered in, the next step is to do envelope entry. The best way we find to do this, and we recommend for most people, is to build a takeoff sheet in Excel first. That way you can account for all your areas in a systematic method before entering them into the program. COMcheck does not have an area calculator like REScheck does. REScheck does have a handy add-in program. You can open up a spreadsheet, enter stuff, and it'll transfer all those area calculations into the REScheck program for you. COMcheck, however, does not have that. So you have to do these things separately in a spreadsheet or very carefully if you're entering directly into the program. Because the only entries into COMcheck, you select your construction type and then you enter in the area of that construction type for walls, for roofs. So to make sure it's accurate, I highly recommend that you build your own takeoff sheet first and track, area entries for walls by each floor. And then for COMcheck, its only concern is what the gross area of each building assembly is. So in your spreadsheet, to limit the number of entries you're putting into the program and limit the risk of errors, you'd want to condense all those data entries for different floors, different orientations, into the fewest number of area types that you can. So if you're entering into COMcheck, say your building has 4 different wall types, you would want to, from your plans, calculate all the areas level by level. Usually I recommend starting and going clockwise or counterclockwise around a drawing to ensure that you don't miss any spaces. And then use some formulas to condense all those into as few spaces as possible. I like to color code mine. You can see an example of this. We took a local library here that had some floor plans for us to use as reference. And so this is kind of the basic takeoff sheet that I built for myself. Same thing for doors and windows. Again, COMcheck really is only concerned with the total area and the U factor applied to that area. So again, you just want to totalize that area associated with each wall assembly type. Another key thing to note, COMcheck is only concerned with the envelope areas that are facing outdoor conditions or unconditioned space. So you're only entering in the thermal envelope of the building. If you've got an unconditioned garage, you're not going to enter in the exterior walls of that unconditioned space. Same thing if you've got a storage area that's not conditioned. Also, important to note, if you've got a basement slab that's greater than 2 foot below grade, that doesn't get entered into the program either, unless it's a heated slab and has insulation underneath that slab. Another important note, for slab on grade, you're going to be entering in the perimeter of that slab into the program and not the exposed area. So just some key things to be aware of in the data entry process. So you can keep that in mind when you're building your takeoff sheet. In this instance, we've got a couple different thicknesses of concrete wall. We had a couple different assemblies. There's a steel framed wall with brick, steel framed wall with limestone, solid masonry walls, and curtain wall assemblies on this building. So we did a takeoff for each of those area types. For entering those into COMcheck, as you can see here, I did a little bit more of a complex example where I entered in each assembly type by its orientation. So if I had a north-facing brick wall and a north-facing framed wall, I entered both of those in for each of the north, south, east, west orientations. It is important to note that that is not necessary to complete a COMcheck. You can just enter in total areas without entering in orientations of those. The only time you would really want to do that is if you're trying to take advantage of U factor and solar heat gain trade-offs for, I know north-facing windows have slightly relaxed requirements than the other orientations. So if you put in the same high U factor window all the way around the building, you can trade that off with some other areas. So again, really important to note there, if you're doing a COMcheck and you want to do a really quick check, you do not have to enter in things by orientation to get a result. You only really want to do that if you're trying to specifically take advantage of trade-offs on orientation-specific U factors and solar heat gain coefficients for your building. Again, if you're building a takeoff sheet, it's going to help a lot with avoiding data errors in transcribing your building plans into your COMcheck sheet. You can see here there's a lot of information, a lot of columns of data to enter in. So very important to make sure you're accurate with entering that data. Another important note, window and door areas get subtracted from its associated wall area when you enter it in the program. So you want to enter in the total wall area, including doors and windows. And then in COMcheck, you can see a couple of examples. There's a highlighted blue line there that's a window entry in an exterior wall. When you enter in that windows area, COMcheck then subtracts it from the total wall area. So if you do that subtraction ahead of time, you're going to be shortchanging yourself on the applicable area in the building, and that can have an impact on your results. So important to note that COMcheck wants the total wall area, including doors and windows in that wall assembly, and then COMcheck does the math to subtract those out for you. So the level of compliance as you're entering in assemblies will update at the bottom of the screen unless there's an error. So you can see in the bottom two here, we had an initial entry for wall assemblies with a 3-inch poly ISO on the roof and no continuous wall insulation that came directly from the plans. And you can see that that did not meet code compliance. So we upgraded that roof insulation to code minimum 5 inches. It would be a R38 and 1 inch of XPS of wall insulation, and that now passes code. So you can see as you make changes in the program, as you enter in areas, this compliance result will update. If you have an area, a case where you've got a TBD, to be decided, display at the bottom of the screen, there is an input error somewhere or some missing data. In the case of the top, we hadn't entered in the linear feet of exposed slab perimeter yet, and so it couldn't calculate a compliance result. The same thing if you're not careful with your window and door areas associated with a wall area. If your window or door area is larger than the available wall area, you'll also get that TBD area error. The other thing is, as you scroll through the rows of data that are entered into COMcheck, if one of these errors is in the program, it'll highlight that number in red. So it should make it slightly easier to scan through and try to locate these errors. One thing to be aware of is if you forget in a row to enter in an R value or a U value for an assembly, COMcheck is going to default to a 0 there. And so if you get a non-compliant result for your envelope, try to go back through and scan for anywhere where you might have forgotten to enter in an R value or a U value. And from our previous screen with all the rows of data, it is easy to accidentally skip over something. We did have a question about Illinois amendments to the IECC. COMcheck does not have an Illinois specific compliance check to it, so it does not account for Illinois amendments in the program. It does have some local municipalities have worked with COMcheck to have their local codes input into the program, but Illinois has not. So no, this does not account for Illinois amendments as far as compliance checks. This is straight off the 2018 IECC printed copies. One certain thing to be aware of in COMcheck, it does not have a curtain wall assembly in it. So how would you enter that into the program? To add a curtain wall, you're going to enter in a other wall type for that assembly and enter in the total area that is associated with your curtain wall. And then you're going to input a window, and if you've got doorways that are associated with that curtain wall, you're going to enter in doorway, U factors, solar heat gain coefficients, and things. The key thing to be aware of, and we've highlighted at the bottom of the screen here, is the total area of the window and door assemblies must be the same area as the curtain wall assembly. So it's important there for curtain wall assemblies that those total areas should be exactly equal. You can see for most of these, the window area matches the wall area exactly. The highlighted section is where there's a window and a door component as well. So again, being very careful that when those entries are added in, you don't have more area than is available for the wall, that total area equals, the total wall area equals the total door and window area. Another thing, when you're entering an other wall type into the program, if you're doing a custom U-factor wall assembly instead of one of their pre-built assemblies, you'll have to enter in a heat capacity. Usually that's contained in the documentation for your curtain wall. If you've got the manufacturer's documentation, COMcheck does do some thermal capacitance checks for the UA trade-off path. It does account for thermal mass in the building. So that's why that input needs to be there. For most window assemblies, it's going to be somewhere between 1 and 1.5 for that heat capacity. And mainly it's to separate the wall assemblies into framed cavities, curtain walls, and mass walls. So that's why that input is important. Once you've completed all the envelope entries into the program, the next thing that COMcheck will walk you through is the interior lighting. So on the project tab, you would enter in your building areas and the associated floor area with those, or the space by space method. If you're doing it that way, you would enter in the individual spaces in the building and the individual areas associated with each space. Those areas would then populate into the interior lighting tab, and you can see here, to keep the display simple, we had one single area, a library area. It takes the floor area, multiplies it by the associated building area in the IECC lighting tables, and calculates your allowed wattage for that building area and the area specified. And then as you enter in lighting fixtures in the program and enter in what wattage those fixtures take up in your wattage allowance, COMcheck will total those up and keep track for you. You can see in the circled area what your allowed wattage is and what your proposed installed wattage is. The other thing you can do is keep track of any exempted lighting fixtures, such as emergency fixtures, anything that's not going to count against that wattage allowance. So you can see here we've selected that exemption drop down, and you can see the full list of exempted lighting fixtures there that won't count against that that wattage allowance for your lighting. One thing to note, if you're doing the space by space method, it does give you a lot more flexibility, as you can trade off lighting wattage between areas, and COMcheck will total up the allowed wattage for all entered areas in the building, or all entered spaces, and check that against your total wattage for those areas. Even if one particular area goes over its wattage, as long as the total wattage for the building is below the allowance, COMcheck will give a passing result. So the space by space method gives you a lot more flexibility, but you do have a lot more detail as far as what shows up on this screen, as instead of having one area with one allowed wattage section, you'll have multiple spaces with multiple different allowed wattages displayed. Another note here that we mentioned earlier on, if you choose the reduced lighting power density efficiency option on the project tab, these allowances will be reduced by 10% automatically for you. So you won't have to do any kind of calculation on your own. It'll automatically be updated on this screen. For exterior lighting, it's the next tab on the program. On the home screen, there's a tab for exterior lighting areas. There you'll be able to select what your lighting zone is. If you've been in our previous presentations, those lighting zones are Zone 1, Zone 2, Zone 3, Zone 4. COMcheck has actually been pretty nice about this in that it spells out different zone types, and it'll attribute to one of those 4 zones for you. So you don't have to guess if you're not sure which each of those zones means. But Zone 1 would be kind of nature reserves and parks. Zone 4 is heavy commercial industrial areas. Zone 2 is light commercial with residential mixed in, and Zone 3 is commercial. So COMcheck has actually spelled out each of those zones here, and will then associate with the proper zone for you from the code books. Again, on the project tab, you're going to be entering in individual areas and associating a square footage with those areas. For pathway lighting, you're going to be associating a linear distance. Those will then populate into the exterior lighting tab. You can see here we've spelled out a parking lot area, an entry pathway into the building, and some illuminated area of the building facade. Again, COMcheck takes the area that you entered on the project tab, multiplies that by the wattage allowance from the code tables, and displays that on the screen here for you so you can know what your total allowed wattage is. And then as you enter in fixtures and wattage, it keeps track of what your proposed value is. If any of your proposed values exceed your allowed wattage, COMcheck will display a red TBD display at the bottom of the screen to let you know there's a problem that's not in compliance. There are also certain areas in outdoor lighting where you can trade wattage between different areas. You can see the first two, the parking lot and entryway. Those are tradable wattage allowances. So if you exceed one but are under in the other and the net result is zero, COMcheck will still display a passing compliance. But if you exceed wattage for an individual non-tradable area, then COMcheck will display an error result. And as you can see, it'll highlight that area in red in the entry row so that you can find it easily and correct those inputs.
One thing to note on that chart in the previous slide is high activity metropolitan commercial district is only available within the city of Chicago here in the state of Illinois, and only as designated by the local land planning commission. So that would only be a very restrictive category. So that's not talking about commercial districts in Rockford or Champaign-Urbana. That's not what that is talking about.
Thank you. The last kind of detailed entry in COMcheck is the mechanical systems. You'll pick first system types. We'll be able to pick whether it's a multi-zone system, a VAV system. As you enter in, if your building's got multiple systems, you can see here we've displayed a number of them. COMcheck will then ask for heating capacity and cooling capacity of each of those. And most of this is for documentation purposes and to populate checklists at the end of the program for verification purposes. The only thing that COMcheck checks here as far as compliance is your total connected fan power to your system. It checks that total connected horsepower against allowable horsepower in the code and gives you a pass-fail result. You can see in this building the red text in the fan system details column on the right side there. Most of those are in red. That's because most of those did not pass that horsepower check. If they were passing, you would see that text in green. One thing to note, if you're looking at the top left corner there, the blue text says HVAC system, plant, water heating, and fan systems. I would not follow that entry order. I would start with fan systems first, because you have to associate a fan system with your HVAC system. If you don't do that ahead of time, there can be some confusion with entry and making sure things are properly associated with each HVAC system as far as which fans are attributed to it. So I recommend doing that fan system first. It builds a library of the available supply, return, and exhaust fans. And then once you've got that library built, then go through, associate them with the individual HVAC system, then do your plant entry for chillers, boiler systems, and then your domestic water heating systems. Specifically on that fan system data entry library, this is what that screen looks like. There are two methods to enter those fan horsepowers. You can do it directly with a horsepower entry for the nameplate horsepower on the fan, or you can do it by a calculated brake horsepower method. That brake horsepower method gives you a little bit more flexibility, as you can associate high pressure drop credits with those fans that give you a little bit more leeway in what your allowable horsepower is. So entering the direct nameplate horsepower for the system is the easiest route, but entering by brake horsepower gives you a little more flexibility. Again, if as long as your fan system's proposed brake horsepower or nameplate horsepower, if that's the path you've chosen to enter those, is less than the maximum allowed, it'll be indicated with a green check mark that it's passing. Otherwise, you'll get the red X. When adding fan systems into the program, the first row should be your supply fan, and that should have the design air volume for that supply system. That first CFM that you enter for the supply side is going to determine your total maximum allowed allowance. So the CFM associated with return fans and exhaust fans that are attributed to that system, do not add additional CFM, design CFM to that system. They just add more horsepower tracking. The reason you can enter design air volumes for those is if you're following the brake horsepower method. That design CFM can be used to calculate that horsepower rating. But again, the key thing to remember is that first supply CFM, that's the total design discharge from the supply fan of the system. That's going to determine what your maximum allowance is for your either nameplate horsepower or brake horsepower of the system. The other components are just recirculating that supply air or exhausting that supply air from the building, so they're not contributing additional airflow to the design of the system. Another thing to be aware of, there's this column here for fan efficiency grade. That is not the efficiency of the fan motor. That is the efficiency of the fan itself in imparting motion to the airstream. And there are grade classes. Usually you should be able to find those in your documentation somewhere or from your mechanical contractor in order to enter that into the program. This is the various available credits for brake horsepower here in this table. So if you're doing the brake horsepower entry for supply fans, then these are the pressure drop credits that you'll be able to get. You can see on the bottom left of the screen here, the option 2 fan system brake horsepower calculation. You've got a little bit more horsepower allowance than you do, or a little bit less baseline horsepower allowance than you do with the straight horsepower method, but you've got the ability to add in these additional pressure drops, which can give you more flexibility. For example, with this particular building, when entering brake horsepower with the design CFM that we had for the building, our allowance was only 18.85 horsepower for the 14,500 CFM system. When we changed that to the brake horsepower compliance method and added in, we had return and exhaust airflow control devices such as VFDs. We also included a high efficiency filtration system that increased our horsepower allowance to 22.5 from that 18.5. So you can see there are ways, depending on the design of your system, to increase those allowances and tweak your compliance. So if you're having trouble getting compliance with the straight horsepower entry, you may look into doing the brake horsepower entry and seeing if that gives you a little bit more flexibility. Is the fan efficiency grade required to be entered into the program? I believe it is required in order to have, there are compliance checklists in the program at the end. You have to check off that you verified that that fan efficiency grade meets the fan efficiency grade requirement in the IECC. There are tables for that. I would have to look up that reference number, and I'll try to do that and send a message out to the group while Ryan's doing his REScheck presentation. But it does not affect the compliance of the system as far as your brake horsepower calculations. It only affects your checklist compliance at the end. So the final tab in the program is the code requirements checklist. This goes through all your prescriptive requirements in the code. And for each entry that you've put in for the envelope, interior lighting, exterior lighting, mechanical systems, those will populate checklist items here for you. Items that are not attributable to your building will be excluded. So that does help narrow down this checklist to only what's applicable for your building. That's helpful for you so that you're not having to check everything, and it's helpful for the code official so that they know specifically which items they have to check for in your construction documents and verification documents. You can see here in the bottom right screen, as you go through and verify compliance, you'll see a checkbox there. You'll check that the requirement has been met. And then in most instances, you'll be able to enter in a plan reference page or a section in your construction documents where that compliance information is indicated. Again, that's helpful for your code official. They've got a handy reference and go, okay, that's on this page of the construction documents. They can flip right to there, verify it, instead of having to hunt through and find those things themselves. As far as the output reports, for the envelope and lighting design of the building, COMcheck has a really handy color-coded bar at the end of the report that says whether your design passes or fails the energy code. It also outputs the spreadsheet table references. You can see a couple columns here for the basement wall data, a couple of things here for your lighting entry in the middle image there. For the mechanical systems, it does not highlight pass-fail for those fan systems. Each system type description at the end of the description will have that pass-fail result there. I've highlighted them so you can see them, but COMcheck doesn't highlight that. So it's a little harder to scroll through the output report for the HVAC system and see that pass-fail. And I kind of wish COMcheck would be updated to indicate that so it's easier to locate. But again, it does track that on the data entry side for the designers who are inputting into the program. This is more just a difficulty for the authority having jurisdiction, the code officials that are looking at these reports and trying to verify compliance. With that, summarizes most of the COMcheck program. I will hand it over to Ryan to overview the REScheck program.
Thank you, Sean. Something else that may be helpful for plan reviewers, for design professionals when you're submitting your plans for plan review is when you do see some of those green pass boxes, if it does have a substantive percentage better than code, that may be something that you might want to highlight to your code official as far as where they might see that you've built a better building than required, because that may cause the plan reviewer to look and say, well, is something wrong here? And you can help key them where to look as far as, yes, I really did build a better building than was required. So as far as REScheck, as we go through this, you'll see that several of these aspects are similar to the COMcheck. As Sean noted earlier, the DOE is looking to move away from the desktop versions of these softwares and moving more towards a web-based version. Another benefit of using the web-based tool is you don't have to constantly check and see, am I using the latest version? Because as you log in, you will be operating under the most current version of this. So something that you will notice here is some of these inputs are a little more simple or simplified as compared to the COMcheck version. So another functionality that's built into REScheck, and we'll talk a little bit more about it later, is that it does have some performance compliance capabilities to it, whereas COMcheck is just prescriptive with some UA trade-off capability. So some of the inputs that you do have here will depend on if you're using the UA trade-off or just strict participation or strictly prescriptive entities or entries. So as we're going in very similar to the commercial sector or the commercial side, again, helping make your takeoff sheet. In residential in particular, we see very beneficial to first identify where our first thermal boundary is as far as the envelope, because oftentimes we will see that there are several portions of a residential building that may not be here in the thermal boundary, and could be storage spaces, it could be garages, could be attics, and the like. So first, we definitely want to identify our thermal boundary and then begin to make our takeoff sheet. Another thing that does simplify this, again, is if you're either using a UA trade-off or the prescriptive in the residential sector, you don't have to concern yourself with orientation. If you are doing building performance, then you do have to have orientation, and it does require you to have at least 4 walls, 1 ceiling, and 1 floor. So you must have all 6 sides for a performance method. So with this, again, we're looking at watching out for spaces that are not conditioned, such as attics. So if you do have a second floor with attic spaces, you might end up with a little bit more complex methodology as far as entering, because you're going to have walls, sloped cathedral ceilings, as well as potentially flat ceilings. So you might have 3 different geometries to enter when you're dealing in these. Attics and unconditioned spaces, that is not part of the conditioned area, and so you wouldn't count walls between attics and the outside if they're unconditioned. So being aware as we're going through and entering that. As far as crawl spaces, if they're vented and therefore unconditioned, then we need to make sure that we're calling those out and entering that properly into REScheck. So the floor above the crawl space would need to be entered, as well as the wall between the conditioned basement and a crawl space would also need to be entered. Also, as noted here, the walls facing between basements and crawl spaces are going to end up with below grade and above grade wall sections. So those will have to be entered independent of one another. And we'll look a little bit more at this here. So here we're looking at a attic area. So we've got a flat ceiling with raised or energy trusses, as well as a cathedral ceiling. So we've had to break this out. That is something that is a little different here in the REScheck version as opposed to COMcheck, where here in the REScheck area, the slope ceiling and the flat ceiling we have to enter independent of one another, as REScheck will not, doesn't delete or remove the slope ceiling from the total flat ceiling area. So we do have to count those separate. And again, this is where Excel can help as far as trying to take into account some of these differences. So as far as when we have the actual entries, beginning obviously our location and what type of project. Here you notice it is differentiating between single and 2 family homes and multifamily. Part of that will go back to compliance paths as far as which group type you are, along with are you likely in the IRC or IBC, the International Residential Code versus the International Building Code. Also going through, how much conditioned floor area, what code version are we using, and also noting, are we doing a UA trade-off or are we doing a performance alternative? A UA trade-off in residential does not necessarily require you to take advantage of the UA trade-off. A standard straight prescriptive method is also falls under that UA trade-off method as well. So it also asks for several questions about the features. Some of those are looking at, are we dealing with fully buried insulation or fully buried ducts in the ceiling insulation? Do we have any sunrooms that are thermally isolated? Do we have pools or in-ground spas? And some of these will go back to checklists as far as compliance. So a pool or in-ground spa, it's likely to put in the checklist, looking at do we have site recovered energy or do we have a pool cover on those? So a few of those are just checklist items towards the end. So as far as our envelope entries, so again, here we're showing, we're going to call this the flat ceiling, and we're using either a raised or energy truss. In this case, they do have several other options, and then we're going to put in, what our total area is and our cavity and continuous R values. So walls can be of several different types, regular framed, either 16 inches on center or 24, using a little bit more advanced framing. It could be log home, structure, SIPs or structural insulated panels, or ICF insulated concrete forms. So for walls, and then when you get into foundations, again, we're looking at masonry, framed foundations, or ICF. And again, with foundations, you can have those split between below grade foundations and above grade. So when you have basements that are partially below and partially above, you can split those out. So this is a look at what the envelope entry looks like. So here again, we're going to select that we're choosing a solid concrete or masonry foundation, total area, our insulation values, and then here it's asking for total wall height, and then how much of that wall height is below grade. So here we're stating that it's a 9-foot wall height with 8.5 foot below grade. So that's stating that we have half a foot that is above grade in this basement wall. And then it will ask you for your depth of insulation. Again, this is where you may run into some challenges as far as compliance, noting that this is not going to account for Illinois amendments. So here requiring your depth of insulation, because I do know there is an Illinois amendment as far as your depth of insulation and your level of insulation, particularly in the northern climate of Illinois. So here, looking at a wall assembly, we're selecting a wood frame, standard construction of 16 inches on center, and then providing the basic inputs from there. So here noting orientation is only if you're doing performance path, because unlike in commercial, the residential UA and solar heat gain coefficients are not orientation specific. So that can help you as simplify this. So when you're doing your takeoffs and doing your inputs, not having to worry about the orientation can be nice, a nice benefit for this. So compliance for lighting, and then HVAC is looking at, again, more just checklists of things, lighting, things such as is 90% of the fixtures inside and outside high efficacy lighting. So some things to note here for REScheck is several of their performance path reference design attributes. Some of these, the REScheck does not allow you to change some of these. So if you do have low leakage ducts or a much tighter air envelope than 3 air changes per hour. I will note again here, the program's default is 3 air changes per hour, which is the International Energy Conservation Code stated value. So if you do have tighter envelopes and tighter ductwork, REScheck does not allow you to change that. So that can be a little bit of a challenge there. You may have to use a different program if you want to use the performance path and take advantage of some of those. You might have to use some other reference or some other energy design software. So other than these, everything else just matches whatever the proposed design is. So if you use as noted here, if you use high efficiency mechanical systems, it doesn't reflect that in the model because they're both going to model it the same as high efficacy or high efficiency. So as far as performance path, noted earlier, you got to have at least 4 walls with different orientations, a roof and a floor. Here, again, noting most of this is just a little more details in having to do your orientations for the different walls and windows for that. So, did have a quick question to touch on the basement walls again. Looking at this, it asks for what is your full wall height and then how much of that wall is below grade. Here in this example, we're stating that the full wall height is 9 foot and that 8.5 foot of that 9 is below grade. So I have half a foot above grade and then 8.5 below grade. And we're insulating the depth, the full 9 foot of the wall height. So that does give you a few different opportunity or few different input metrics.
To further address that question, the Illinois amendments do allow for that insulation to stop 6 inches above the floor, where the code requires that insulation must go to the bottom of the floor slab, so it must touch that floor slab, or be 10 foot below grade, whichever is less. Just to clarify those insulation requirements.
Also have a question here as far as the Illinois amendments for the 4 air changes per hour per the Illinois amendments. The REScheck does not allow for that to be changed. Again, this is goes back to Illinois. Illinois has not provided resources to make a specific program version for REScheck for the state of Illinois. So that may be something that when it goes through and checks, it may give you a warning saying, hey, verify this. And that would be something where the code official would have to be, they would understand that the Illinois amendments would have it as 4, even if the REScheck modeled it with 3.
The way REScheck would handle that, the way they've done it for other areas, is they build a custom code compliance. So instead of being the code referencing the 2018 IECC, it would be, I know New York has their own code in there, Oregon has their own energy code in there, and that's where they would account for if Illinois petitioned COMcheck to have their code added, then they would change that air change requirement then in the programming of the program. But no, you cannot change it as an input into REScheck yourself. We also had a question here. Is the full height of the basement wall basement to floor framing or concrete? So if you've got I'm assuming that question is asking if you've got a split wall where the bottom part is masonry and the top part is wood framed, how would you enter that into COMcheck? You would enter that as two separate wall assemblies, and you would enter in, the framed wall section is above grade foundation wall. It's part of the basement, but it's foundation wall. So you would enter that into the foundation section as a framed wall, entirely above grade. So in that question where it asks how much is below grade, you would put a 0 there, and then it would attribute that entire assembly above grade. And then the concrete wall that's supporting that wood framed wall above, that would get entered separately, and you would split that for how much of that wall is above grade and how much is below. We also had a question. Can we go back quickly to the performance method and show the entries? We can go back to that slide real quick. So this is also included in the, there's a total table in the IECC that has these performance path requirements. So this information was copied from table R405.5.2. And so we went through and just tried to summarize here things that can be changed in your proposed model versus the reference design model. Anything that's not listed here, they're going to be the same values. So like the HVAC system, if you specify a high efficiency system for your proposed model, the base model is also going to have a high efficiency HVAC system. So really the places where you can get the most benefit from a performance path model is if you can reduce leakage rates in your ductwork and the building envelope and reduce those air changes. And then also the U factor trade-off for different building assemblies.
I have a question here regarding City of Chicago and insulation levels for residential buildings. So that's buildings that are 4 stories and less within the City of Chicago, 3 stories and less across the rest of the state, where residents reside on a permanent basis that would be mixed use or multifamily. The tables called for in the code state an R20 in the walls or R13 cavity plus 5 continuous for wood framed walls. Mass framed walls have a little bit different lower values, and then ceiling is an R49 for residential buildings. So those are the tables here. I believe the difference for that there's an Illinois amendment which includes City of Chicago is for basement wall R values.
We did have a question here as well that came up in the chat. Explain the difference between cavity and continuous insulation value. So the R value there is going to be the manufacturer's R value for the material. But But the difference between cavity and continuous insulation is cavity insulation is inserted between framing members, so between steel studs or wood studs, where continuous insulation is going to cover the entire opaque area of that wall assembly without breaks or thermal bridges. So that would be the difference in cavity insulation and continuous insulation. As far as entries in the program, COMcheck separates those out as separate inputs. So you would input an R value for your cavity insulation and a separate R value for your continuous insulation, and COMcheck does the math for you. Unless you're doing a U-factor entry for an entire wall assembly, if you've got a custom assembly that doesn't match one of the pre-built assemblies in COMcheck or REScheck, in that instance, you're going to enter in the total calculated U-factor for the opaque surface of your wall area, including any framing and everything else in it. And you're going to enter just a single U-factor value, and you'll have to enter in COMcheck a heat capacity value. In REScheck, I believe you also have to enter that heat capacity value. And that helps differentiate between framed assemblies, which are going to have a very low heat capacity, and mass assemblies, which will have a higher heat capacity.
A question here as far as does REScheck still interface with Write Suite software? That is something I'm not familiar with. I don't know, Sean, if you have any guidance on that or not.
I do not. I would have to look into that. I was unaware there was interface ability to begin with. So yeah, we'll look into that and we'll get an answer back to you.
Question here as far as looking at mechanical equipment and looking at our HERS rating. Question is if a HERS rating would produce a better performance path. Does a HERS rating provide an ERI that would take benefits of better performing HVAC equipment? ERI is a different path than the performance path, or that is another type of performance path that is different from the REScheck performance path. Something to be aware of is a HERS rating and the ERI are closely related, but they are not the same. So that is something to consider as far as if you are doing a HERS rating on a building, you may also need to you would also need to do an ERI path compliance in addition to the HERS rating. Many of the other softwares out there may provide a little bit more accuracy with a little more detail, which could be beneficial for buildings that are right on the hair of compliance or not. Yeah, a HERS rating or an ERI compliance method is different, but may provide similar results.
Again, when is the desktop version going to be phased out? We're not sure. We don't have a definitive date yet that's been announced. We do know it is a planned phase out. So eventually the desktop version will not be updated with new code versions. If you're still trying to apply to existing code versions, it'll still be a usable software. But if your jurisdiction upgrades to a newer code cycle after the phase out of the desktop version, then you will not be able to use that for a compliance check. We don't know when it will happen. We just know that they're planning on it. As soon as we hear anything, we'll be sure to announce that in a newsletter article or on our website. And to the last question about the foundation walls, typically the question was specifically about the rim joist framing on top of the foundation wall, whether that's entered. I will have to check. I'm not sure whether the program defaults in a specific rim joist there, or if you have to enter in that data yourself. From what I've seen in training and stuff, the rim joist is not entered, but I will verify and make sure, and we'll shoot you an email with that detailed information.
We also have a question here as far as the COMcheck compliance checklists. Should they be completed by the building official or by the designers? I would encourage them to be checked off by both. So that way the initial designer goes through and does a verification to help check that something wasn't missed. And that's very useful to go through as an initial check rather than turning it over to the building plan inspector and have them find something missing. So best practice would definitely be have both the design professional complete the checklist first, and then go ahead and submit that with the plans, and then the plan reviewer can also do a verification on it. It makes it much quicker and easier to do.
We do have another question here about where do the 3 air changes per hour relative to other higher values we encounter. Where is it relative to diminishing returns? What does that 3 ACH mean as far as your compliance? Typically what we find in a lot of residential construction now that people are used to doing that air sealing, that 3 air changes per hour is usually beaten. It's uncommon now for most newer buildings, new residential buildings, to be above that 3 air changes per hour. And I do know in the next code cycle, Illinois is planning to align with the rest of the IECC jurisdictions and align with that 3 air changes per hour. As far as renovations go, air changes per hour is not a requirement to check in those buildings unless you're doing a full house renovation where you're essentially ripping the walls down to the studs and starting over from scratch.
Once again, I do want to thank everyone for their participation today. Again, if you do have other questions, please feel free to email us, energycode@sedac.org. And we are happy to help with technical assistance you may require for the Illinois Energy Efficiency Code. So thank you so much.